Here's a great example of the capture recapture method right out of the back of your textbook. This is section 1.2, and I thought we'd go through this problem just to sort of get an idea of how to approach these kinds of problems. And the first step is just to carefully read the problem and identify what kind of problem you're dealing with. And by that I mean that you're not always going to be told that you need to be using the capture recapture method in order to find the total number of fish in the lake. In this case, the call to the question may be vague, and you might not be even given the formula that you need. So figuring out what the question is asking for exactly is very critical to these kinds of problems. So let's carefully read it and see what we've got. The Fish and Game Commission sent out a representative to determine the number of fish in Finn Lake. Well, right there we know that we're asked to find the total number of fish in the lake. Find the number of fish in Finn Lake. There's our required right there. He set traps that caught 80 fish from the lake. Okay, well, that's a sample that was taken right there, 80 fish, which were marked and then released back into the lake. 2 days later, the trap caught 65 fish. There's another sample. That's sample 2, of which 8 fish were marked. So we had 8 fish marked in the second sample. Estimate the total number of fish in Finn Lake. There's your required. So we've got our given, we've got our variables, and we've got our required. So if we're already aware of what the capture recapture method is, then we can tell ourselves, hey, you know what? That's the formula that we need to use for this. So let's go ahead and write down that formula from what we already know. We know that the capture recapture formula is as follows. M is equal to B times N over A, where M is equal to the total number. In this case, it'll be fish. B is equal to the number collected in sample 1. Sample 1. N is the number collected in sample 2. And A is the number in sample 2 that were previously marked from sample 1. So marked number in sample 2. Now, in case that sounds a little bit confusing, realize that it might be a good idea to backtrack a little bit and mark each of these variables in the problem statement in the call to the question. So M, total number of fish in the lake. That's this quantity here, M. Okay, total number of fish in the lake. That's what we're asked to find, and that's all by itself over on the left, so we're already set up pretty good there. Sample 1 is B, number collected in sample 1. Well, he sets traps that caught 80 fish. So 80 fish is going to be our B. That's B. Which were marked and then released back into the lake. 2 days later, 65 fish were caught. Well, that's sample 2, 65 fish. That's N. Is 65 fish, of which 8 fish were marked. So in the second sample of 65 fish, 8 fish were marked. So A in our equation is 8 fish. So there we go. We have all 3 of our variables, and we have what's known identified in the problem statement. So now we're free to continue with the problem. So, like we already know, we got to set up the problem. We already have our equation written down. We know 3 of our variables, and we're looking for the 4th. We don't know what M is, so M stays M. We know that B is equal to 80 fish. 80 fish. Times N, well, N, 65 fish. All divided by A, which, all divided by A, which in this case is 8 fish. 8. fish. Now all of our variables are filled in this equation except for one, m, and so we can go ahead and solve to determine the total number of fish in the lake, m. So let's create a little section over here to do side work. Side work. First of all, let's multiply the numerator out to give us a nice solid number. That's going to be 80 fish times 65 fish. So 80 fish times 65 fish. Well, fish times fish is fish squared. Fish squared. 5 times 0 is 0. 5 times 8 is 40. Add a 0. 6 times 0 is 0. 48. Sum it all up. We've got fish squared. It's 12 and 5. 5,200 fish in the numerator. Fish squared in the numerator. So let's take that back over. We're going to replace this entire numerator. Since we multiplied these two terms together, we're going to replace that entire numerator with our 5,200 fish squared. So m, the total number of fish, is equal to 5,200 fish squared divided by 8 fish. I should point out that we're looking in the end to have what? Let's go back to our problem statement. We're looking to determine m, which is the total number of fish in the lake. Fish in the lake. So our units for this is going to be fish, right? So that being said, we know we're on the right track because when we go to execute this division of 8 into 5,200, this fish is going to cancel with one of these fish up here, and we're going to be left with a unit of fish. So we know we're on the right track because m is going to equal to some number of fish. So we're on the right track so far. And finally, let's execute the division. So 8 goes into 5,200, 6 times for 48, remainder of 4. It's 5 times. 5 times for 40, with a remainder of 0, 65 times. Doesn't seem right. 65 times 8. This is 40. 52 is 50. 2 is 520. I'm missing something here. 0 times. Bring down the 0. If 8 goes into 0, 0 times for 0. Anyways, 650. So m is going to be equal to 5,200 fish squared divided by 8 fish squared is 650. And again, this fish cancels with one of these fish. Final units of fish. So our final answer of the total number of fish in Finn Lake is 650.